Tecaxic-Calixtlahuaca head. An archaeologist working in the Toluca Valley lifted a tiny fired clay face from a sealed burial layer in 1933. The team found it with gold, copper, turquoise, rock crystal, jet, bone, shell, and pottery. The surrounding graves dated to just before first contact between Europe and the Americas. On first glance, the face looks Roman. The nose and the way the lips are modeled remind people of classical busts. That visual shock is what turned a small object into a big question. Scientists ran thermoluminescence tests in 1995. The results were broad. The tests suggested the fired clay could be as old as the 9th century before the Common Era, or as recent as the 13th century of the Common Era. Other studies focused on context. The soil around the find carries mineral crusts that match the burial layer. That detail argues the piece was there a long time. Critics point to possible contamination, or to the plain fact that strange objects can move into old layers during messy digs. Some suggest the head was planted during or after excavation. Either way, many scholars prefer conservative explanations. A smaller set of researchers ask a bolder question. Could small accidental contacts across oceans have left odd items without leaving a clear written trace? That idea is tempting, because a single artifact like this can wobble a tidy timeline. But the stronger claim needs stronger proof. Right now, the evidence pushes and pulls. The tests keep the mystery alive, and the context keeps the debate honest. The tests are the heart of the debate. Thermoluminescence dating in 1995 placed the fired clay in a very wide range. The lab results did not give a neat year. They said the piece could be ancient or medieval. That uncertainty matters because it keeps multiple stories alive. Soil analysis matters too. The minerals on the surface of the head match the burial layer. That detail argues the object sat in place a long time. Critics answer with practical doubts. They point out that old sites are not tidy. Roots, animals, and human activity can move things down into older layers. They also note that small objects are easy to misplace or to introduce during excavation. The excavation records from 1933 are not as complete as modern teams would prefer. That gap gives room for skepticism. Advocates who see real contact stress stylistic matches. They compare the facial features with classical Roman work and note similar modeling. A few scholars proposed indirect trade or ancient ship drift as possible mechanisms that could put Roman-style goods on American shores. Mainstream archaeologists remain cautious. The consensus view is not that the artifact proves trans-ocean contact, but that it demands careful study. To settle the question decisively, scientists would need tighter dating and more context. A direct way forward is more precise material analysis like isotope sourcing to find chemical fingerprints that tie the clay or pigments to a region. Another test is a re-examination of excavation records and any overlooked objects from the same layer. For now, the little head sits between two options. It could be a lonely, puzzling trace of contact. Or it could be a troubling example of how easily stories grow around a single object. Westford Knight. A figure carved into a glacial boulder in New England looks at first like a medieval warrior holding a sword. Local writers first mentioned the mark in the late 19th century. Some later researchers argued the shape of the shield and sword match 14th century Scottish motifs. That idea fed a story that Prince Henry Sinclair sailed to North America long before Columbus. The claim has energy because people like a clear, dramatic story. But the evidence is thin. Stone weathers. Cracks grow and shapes emerge that later eyes read as faces or tools. Field records from early reports are sparse, and impressions shift over time. In the 1950s, a scholar proposed the night reading, and that view found a small audience. In 2007, a forensic geologist studied wear and concluded the weathering patterns could be old, but he stopped short of a definitive medieval date. Critics point out that a single carved image without associated artifacts is weak proof for trans-ocean contact. Supporters point to a nearby carving of a single masted ship discovered in the 1920s, and say the two together form a pattern. Skeptics answer that the boat image could be a later addition or a chance resemblance. The debate illustrates two common traps. The first is reading modern identities into vague marks. The second is letting local legend become evidence. What would settle this one are dated tool marks or secure associated finds from a clear archaeological layer. Until then, the rock is a story waiting for better proof. Supporters often point to a nearby carving called the Boat Stone, which shows a single masted ship. That discovery in the 1920s added fuel to the Sinclair story. The pairing of a warrior-like figure and a ship image is persuasive at a glance. Persuasive is not the same as conclusive. The long list of missing pieces matters more to experts. There are no securely dated tools found near the carvings. There are no medieval coins or camp remains. There is no clear layer of human activity that ties the images to a single ancient event. Weathering plays tricks. Rock cracks and moss patterns change the way a surface reads over decades. A shape can look like a shield one year and like random erosion the next. The forensic geologist who studied the site in 2007 argued the weathering could be old. He did not claim a firm medieval date. That careful phrasing is important. Archaeology rewards what can be repeated and measured. What would change minds is direct material evidence. A dated tool mark carved into undisturbed rock would be strong. Organic residue sealed in an ancient fill that radiocarbon dates to the 14th century would be strong. A small assemblage of European-style artifacts found in a clear layer near the carvings would be stronger still. Absent those things, the carving remains a powerful local myth that may or may not record real contact. If the images did come from medieval visitors, the implication is not a neat rewrite of history. It would suggest isolated voyages or visits that left few records. If the images are chance resemblances, the story shows how eager we are to read our past into random marks. Nimrud lens. Layered, uncovered it in 1850 while clearing the ruins of an Assyrian palace. The piece is a small oval of rock crystal, about 4 centimeters long, about 3.5 centimeters wide, and under 1 centimeter thick. It is polished and ground in a curve that focuses light at roughly 12 centimeters. The finish caught scholars off guard, because the grinding shows care and skill. The surface is smooth enough that the object can act like a simple magnifier. That raises the first obvious question. Did someone use it to read small marks or to work on tiny details? The manufacturing technique is unusual. The shape suggests a toroidal grind, a form that can correct certain visual distortions. Engineers testing similar pieces found they can enlarge small writing and can focus sunlight enough to ignite dry tinder. That means the object is capable of useful optical work. Scholars offer several practical explanations. One is that it was a magnifier used by craftsmen who engraved gems or painted fine details. Another is that it was inlaid as decoration to catch light and show wealth. A more dramatic idea is that it was part of an optical instrument used for observation or astronomy. The telescope theory sounds exciting, but it runs into a gap. We lack a clear record of supporting parts or of written instructions for building compound instruments in that place and time. The simplest interpretation fits the immediate evidence best, yet the lens forces a larger point. Lab experiments sharpen the mystery. Modern researchers and hobby engineers have tried to see what the lens can actually do. When placed over tiny letters similar to cuneiform, a replica lens can enlarge the text enough to help with close work. When focused in bright sunlight, similar pieces will concentrate heat and ignite dry tinder. Those outcomes are simple and repeatable. They show the lens is not merely decoration. At the same time, the tests expose limits. The optical quality is not equal to what a modern instrument provides. Distortions remain at the edges, and the focal field is narrow. That makes the idea of a compound telescope unlikely without other parts that we do not find. Another useful line of testing looks at wear and tool marks. Microscopic study can reveal how the surface was worked and whether it underwent later polishing. Chemical analysis can show if residues from adhesives or metals cling to the edge and point to a mounting or inlay use. Simple replication is a practical experiment too. Craftspeople tried to reproduce the grind with ancient tools and found it is difficult but not impossible. That result matters because it shows skill rather than magic. The bigger implication is this. If craftsmen 27 centuries ago knew how to grind usable optics, then some knowledge was advanced and practical. If that knowledge faded, it would not be unheard of. Technologies appear and disappear across history. To settle matters decisively, we need a workshop context. Finding grinding debris or tools in a dated Assyrian layer would change everything. Absent that, the lens is a clear sign of skill, and a stubborn question about how much ancient people could do with simple objects. Sabu Disk. Archaeologists lifted it from a First Dynasty tomb at Saqqara in 1936. The object is carved from metasiltstone. It measures 61 centimeters in diameter and stands about 10.6 centimeters high, with a central hole roughly 8 centimeters across. The form is odd and elegant. A thin hub rises at the center. 3 curved lobes extend outward, and the rim bears biconvex perforations that look almost engineered. The stone is fragile. Working such material without cracking it takes steady hands and careful technique. That precision is the first shock. How did craftsmen drill a neat central hole and carve symmetrical lobes in a stone that likes to split? The tool marks tell a story. Experts argue the carving shows coring and drilling consistent with copper chisels, bow-driven drills, and abrasives like quartz sand used for shaping and polishing. Those are well-known ancient methods, but applied here with unusually tight control. The find context matters too. It came from a burial chamber among objects linked to food and offerings. That fact feeds a simple explanation. The disc may be a ceremonial vessel or a ritual object meant to hold offerings. Another practical idea points to brewing. Beer mattered in ancient Egypt, and the lobe shape could assist mixing or draining. A more speculative reading treats the disc as a mechanical component, a flywheel or hub for a device. That reading attracts sensational attention because the shape resembles modern parts. Sensational claims have little direct evidence. The safer view ties function to the tomb context and to known pottery and ritual practice. Still, the craftsmanship remains puzzling. Researchers tried to make the disc do useful work. Craftspeople and engineers carved replicas and tested the lobe shape for stirring and for rotational balance. A stone copy can move fluid when spun slowly. It can act like a paddle and stir a mash. That supports the brewing tool idea. At the same time, the original is fragile. Repeated use would risk cracking. That argues against heavy daily use in a workshop. Replica tests of the central hub looked at mounting possibilities. With a shaft through the hole, a disc can turn evenly, but the original shows no obvious wear ring that matches frequent rotation. Microscopic study of the surface found fine drill marks and polishing pits, consistent with bow-driven drills and abrasives. Those marks prove skilled technique. Chemical tests aimed at residues found nothing conclusive. No adhesive traces or metal filings appear in published reports. That weakens the argument that it was mounted in a machine with metal parts. The mechanical component theory still has appeal because the shape mirrors modern hubs and flywheels. But machines need supporting parts that we do not find in the tomb. The ceremonial vessel idea fits the burial context. It was placed among offerings and food-related items. A ritual object would explain the care with which it was made and the decision to use a fragile stone. The brewing hypothesis connects to known Egyptian beer production, and the lobe design could aid mixing, so the tests paint a mixed picture. The disk proves remarkable skill. The tests do not prove a hidden ancient engine. What would settle the matter decisively is finding a workshop context. Grinding debris dating to the same layer or tools with matching wear would show production for practical use. A set of associated machine parts would show mechanical intent. Or a clear set of ritual inscriptions would tip us toward ceremony. Abydos helicopter, high on a temple lintel, a cluster of carved shapes, looks to some like a helicopter and a submarine. The image is striking because the outlines seem so familiar. That is why this lintel turned into a viral curiosity. The quick answer is not ancient flying machines, but overlapping carvings and the way our brains make sense of chaos. The temple was carved in the reign of Seti IV around 1290 to 1279 before the Common Era. Later, during the reign of Rameses the Great around 1279 to 1213 before the Common Era, artisans recut and updated many inscriptions. Where the older work and the newer work overlap, the lines cross and merge. From a distance, those merged lines form odd silhouettes. Egyptologists studied the lintel closely and mapped the two separate layers of lettering and royal names. When you remove the later cuts in your mind, the original scenes reappear. That method is plain and repeatable. Experts read the signs, trace the original names, and show how the composite shapes emerge from superimposed glyphs. The second factor is pareidolia. Your mind fills missing pieces and completes shapes into things it knows. A few coincidental overlaps, a little erosion, and suddenly a modern machine appears. There is no tool mark or inscription that names helicopters. There is instead a clear record of recutting and restoration. The lesson is that stone tells a layered story, and the eye sometimes lies. Scholars did not rely on guesswork. They used step-by-step methods that anyone can learn. First, they photographed the lintel in many lights. Photographs taken with raking light reveal shallow cuts and subtle tool marks that normal lighting hides. Experts then traced each visible line and compared shapes to known hieroglyphic signs. That tracing separates older signs from newer ones because letter forms change over time. Second, they studied the royal cartouches. Cartouches hold a pharaoh's name. The shapes and spelling inside those cartouches match the known forms used by Seti I and by Rameses the Great. When the names are read in sequence, the older set belongs to Seti, and the later cuts belong to Rameses. Third, they used microscopic examination to read tool marks. Different tools leave different striations and different chip patterns. The older layer shows one style of cutting, and the later layer shows another. Fourth, they applied photogrammetry to create three-dimensional models. Those models let them peel back layers virtually and test which lines lie on top. Each technique on its own gives hints. Together, they make a strong case. The combined evidence shows the shapes are the product of overlapping inscriptions and later recutting. That resolves the helicopter illusion without invoking advanced ancient machines. The bigger lesson is about perception. A few overlapped strokes and a bit of erosion can trigger a modern image in the mind. Dendera lamps. In the dim crypts beneath the Hathor temple, a carved motif looks at first glance like a bulb on a cord with a snake inside. The shape is uncanny because it echoes a modern lamp in a way that makes people stop and ask how. The quick claim is dramatic. Some say it proves ancient electrical knowledge. The stronger answer is rooted in Egyptian symbolism. The carved bulb is a lotus flower. The curling element is a snake representing the divine form, Harsomptis. The pillar-like form nearby is the Djed, a symbol of stability tied to Osiris. Together, they tell a creation story about light and life emerging from the waters. Egyptologists read the surrounding inscriptions and describe a mythic scene. The text names gods and rituals, not devices. Fans of the lamp idea point to what look like cables or tubes. They say the snake is a filament and the djed is an insulator. That reading sounds neat, but it ignores context. Archaeologists check for soot and wiring and for traces of metal. None of those practical signs appear in the temple or in tombs nearby. The absence of soot does not prove electric lighting, because torch and oil lamp use can leave little residue when ventilation and careful maintenance are present. The epigraphic evidence matters most. The inscriptions around the image explain ritual acts and divine birth. Photographs and drawn copies by trained epigraphers match the religious reading. That does not make the image boring. It shows that a culture can make powerful visual metaphors that echo shapes we know today. Experts took that claim seriously enough to test it. Epigraphers read the surrounding inscriptions and found names of gods and ritual phrases tied to creation and rebirth. The carved bulb is a lotus. The curling form is the god Harsamtus, shown as a snake. The pillar-like element is a djed symbol for stability. Those signs fit a mythic scene, not a wiring diagram. Archaeologists next looked for physical traces. They scanned surfaces for soot and for metal residues. They examined stone for drill holes or channels that could hide wiring. Published reports show no consistent soot buildup in the chamber, and no traces of metal wiring or conductive deposits tied to the images. Craftspeople attempted replication too. Replicas carved in soft stone produce the same bulbous shape without implying electrical use. Microscopists examined tool marks and found ordinary carving patterns and polishing consistent with symbolic relief work. Proponents of the lamp idea argue that absence of proof is not proof of absence. That is true, but extraordinary claims need positive evidence. What would tip the scale for experts? Evidence of insulated wiring or metal filaments sealed in context would change everything. Soot patterns that match sustained enclosed lighting and not torches would force a rethink, or a technical manual etched nearby would be decisive. Absent such finds, the safest reading remains symbolic. Iron Pillar of Delhi. It stands more than 7 meters high and has resisted heavy rust for about 16 centuries. The pillar dates to around the year 400 of the Common Era. For most untrained eyes, a standing iron column should be a rusted ruin. This one is not. Scientists asked a simple question: why has it survived? So researchers looked closely at the metal. They found a higher than usual phosphorus level in the iron. That small amount of phosphorus helps form a protective phosphate film on the surface when the metal weathers. The film is thin and adherent. It blocks oxygen and moisture from reaching the iron beneath. Microscopic study shows a crystalline layer of iron hydrogen phosphate that grew slowly over time. Slag inclusions in the metal also helped. The way the pillar was forged created a microstructure that favors stable film formation. The builders produced the pillar by forge welding many iron pieces together. That method trapped slag and made the metal non-uniform in a useful way. Environment matters too. Delhi has seasonal wet and dry cycles that encourage the protective film to crystallize rather than flake away. Modern teams tried to replicate the effect. Some experiments reproduced the film by using high phosphorus ore and careful forge welding. Others failed when they used low phosphorus iron or different heating techniques. Replication shows the effect is real and reproducible, but it also shows it is delicate. The precise combination of ore choice, smelting method, and climate made the pillar special. That raises the next question. Replicating the pillar sharpened what we know. Modern metallurgists tried to copy the effect. They used local ore with high phosphorus. They forge welded lumps of iron the same way ancient smiths did. Some teams produced a phosphate-rich film similar to the Pillar S protective layer. Those replicas developed thin crystalline coatings that slow corrosion. Other attempts failed when the ore lacked phosphorus, or when heating was inconsistent. The experiments show the chemistry and the technique matter. That is important because it moves the story from miracle to craft. The protective layer forms when phosphorus and iron react under alternating wet and dry conditions. Slag trapped in the metal helps seed the film. Forge welding creates microstructures that encourage stable passivation. Put simply, the right ore plus the right process plus the right climate will produce long-lasting iron. Where the mystery remains is intent. Did ancient smiths know this and select ore and method on purpose? Or did local conditions and long experience simply lead to an accidental but repeatable result? Some historians argue craftsmen had empirical knowledge. They point to texts and to consistent choices of materials in other monuments. Others caution that we lack direct records showing deliberate corrosion control. The pillar could be the product of skillful practice rather than engineered design. The next step would be finding workshop waste with matching slag chemistry or a set of pillars made the same way. Those finds would show pattern and intent. For now, the pillar stands as a lesson. Advanced craft sometimes looks like magic until science explains the steps. Ica stones. Farmers in a region of Peru started bringing odd carved stones to collectors, and to a local doctor named Javier Cabrera in the mid-20th century. Many stones showed humans rubbing shoulders with dinosaurs. Some showed advanced machines and oddly modern scenes. Cabrera collected thousands of them and publicized his find with a dream of lost knowledge. The story spread because the images are dramatic and because people want to imagine history rewritten. The reveal came slowly and then fast. In the 1970s, a few local stoneworkers admitted carving examples for sale. They described using modern tools like dentist S-drills and chisels. They showed how they baked pieces in animal dung to speed up patina formation and then sold them to tourists. That confession was powerful. Forensic checks backed it up. Microscopists found fresh tool marks under the surface patina. The patina itself could be faked with simple chemical and heat methods. Many stones lacked archaeological context. They were not dug from sealed layers with datable material around them. Instead, they appeared on the market without provenance. That combination kills the scientific claim. Still, the stones did not disappear. They became a favorite of pseudoscientific groups. Creationist exhibits used them to argue for human and dinosaur coexistence. Ancient astronaut fans used them as alleged proof of lost technology. Scientists and museums responded by showing how proper excavation and independent dating are the backbone of reliable archaeology. The Ica case is a sharp lesson. A striking image is not evidence by itself. You need context, tests, and expert review. The images are hard to forget. Men carving dinosaurs side by side with humans and scenes of modern-like technology is an immediate shock. The story grew because a local collector displayed thousands of these carved stones and suggested a lost ancient knowledge. The turning point came when local stoneworkers admitted making many pieces for sale in the 1970s. They explained how they used modern drills and simple tricks to simulate age. Their confessions mattered, but scientists went further. Microscopic inspection revealed fresh tool marks beneath surface patina. Chemical tests showed patina that could be produced quickly with heat and organic coatings. Crucially, most stones lacked provenance. They were not recovered in sealed archaeological layers with datable material around them. That absence kills scientific claims because context is how we date and trust artifacts. Even so, the stones lived on in exhibitions and in online feeds. Creationist groups used them to argue for human and dinosaur coexistence. Ancient astronaut fans used them as evidence of lost technology. Those choices show how a striking image can outpace careful method. Museums and researchers responded with a simple message. Extraordinary claims need extraordinary context. A photograph alone is not enough. You need excavation records, independent dating, and peer review. The Ica case is useful because it teaches a practical rule. When you see an amazing artifact, ask 3 quick questions. Piltdown Man. In 1912, a gravel pit in Piltdown, England, yielded bone fragments that became the sensation of the age. The finder, a local amateur, presented a skull and jaw that fit the era's hot question. The pieces looked like a human brain case with an ape-like jaw. That combination seemed to answer a deep puzzle. Scientists and the public grabbed the story. For years, the Piltdown remains were touted as the missing link that tied ape-like jaws to larger human brains. The fossil fit the place many expected to find human origins. Europe-centered ideas and national pride made the find attractive. High-profile scientists backed the claim, and museum displays reinforced it. That network of authority mattered. Piltdown did not sit quietly on a shelf. It shaped how researchers read other fossils, and it slowed acceptance of finds from other regions that did not fit the Piltdown template. The hoax also exposed a cultural tendency. When a discovery matches what the community wants to see, skepticism often softens. Scientists still used new methods, but they were influenced by an existing consensus. Crucially, the Piltdown story shows how a single deceptive object can bend the arc of research for decades. Laboratories eventually developed better tests, and other discoveries pointed in different directions, but not before Piltdown had left a long shadow. The exposure came in 1953, when new tests and fresh eyes converged. 3 scientists led the work. Kenneth Oakley applied fluorine absorption testing to the bones. Joseph Weiner and Wilfrid Legros Clark examined anatomy and tool marks. Fluorine testing showed the pieces absorbed different amounts of the element. That meant they had not lain together for the same long time. Microscopic study found file marks on teeth and modern staining in grooves. Chemical analysis revealed substances applied to give an artificial antique look. The jaw turned out to be from an orangutan and the skull from a modern human. Tooth surfaces had been filed down to change their shape. Together, the tests told one clear story. Someone had assembled parts, then doctored them to look old. The revelation reshaped paleoanthropology. Finds from Africa and Asia that once seemed odd compared to Piltdown gained credibility. The scientific community tightened methods. Laboratories developed new dating techniques. Peer review became more rigorous, and cross-checks with independent labs became standard practice. Piltdown taught painful but useful lessons. First, never accept a single line of evidence as final. Second, document provenance carefully. Third, invite independent replication early. Fourth, watch out for confirmation bias where a discovery fits cultural hopes. The hoax also showed resilience. Even after exposure, some long-standing ideas took time to change. Science is correction in motion, not instant perfection. Saqqara bird. Archaeologists pulled it from a burial in Saqqara at the end of the 19th century. The little object comes from the tomb of Pa-di Imen and dates to around 200 before the Common Era. Carved from sycamore wood, it spans about 18 centimeters across the wings and weighs 39.12 grams. At first glance, it looks like a modern model airplane. The wings have a curved profile. The tail is vertical. The whole piece is smooth and carefully carved. That odd appearance is exactly why the bird became famous. Mainstream scholars see a different story. They point out that birds and falcons appear everywhere in Egyptian art. Falcons represent Horus and Ra-Horakhti. Small carved birds turn up in ritual and funerary contexts as symbolic objects. In other words, the iconography fits religious meaning as easily as it fits flight. Alternative ideas say it might be a toy for an elite child or a weather vane. Those are simple, practical explanations that match other finds from tombs. Yet a handful of researchers could not resist asking a technical question. Could the shape actually fly or glide? The story turns on that question, because if it could, then our reading shifts from pure symbol to possible experiment or demonstration. Researchers built replicas and ran tests to see if the little wooden model could really fly. In 2002, a craftsman built a balsa copy and tried hand launches. The replica was unstable, without a tailplane, and glided poorly, even with adjustments. In 2006, another team made a scale model and ran wind tunnel tests. That model produced lift that was several times its weight when thrown correctly. With a small added tailplane, it showed much better glide behavior. Those two results sound at odds until you look closer. Small changes in wing curvature, mass distribution, and where the center of mass sits change everything. A model that lifts well can still be unstable if the center of mass lies behind the neutral point. The most recent study in 2023 used three-dimensional scans and computational fluid dynamics. That simulation found a low maximum glide ratio and showed the center of mass sitting too far back for stable flight. The authors concluded the artifact is not a practical glider. What does this mixed evidence mean? Practically, it shows the shape can produce lift under certain conditions. It also shows the original object would need careful adjustments to become a useful flying device. Archaeologists add another layer. Falcons and bird imagery are central in Egyptian symbolism. Small carved birds appear in ritual and funerary contexts. A toy or a symbolic object fits the tomb setting and the wider iconography. Experimental tests intrigue us, and they teach us about craft possibilities. They do not by themselves prove ancient aeronautical knowledge.